Hello. In this video, we are going to learn about rational exponents and radicals. First of all, a radical is just a fancy word for a cube root, square root. A radical encompasses any power of the root. So let's look at some examples of perfect square roots. This is a radical of second degree. We have the square root of 164 and the square root of 16. We know that these are perfect square roots because I know that the square root of 16 is the same thing as the square root of 4 times 4. Therefore, the square root of 16 is 4. Same thing with 164. Well, first of all, this was supposed to say 169. I mistyped. And I know that the square root of 169 is the same thing as the square root of 13 times 13. Since I see two copies of 13, I know that the square root of 169 is 13. Let's look at some examples of perfect cube roots. I have the cube root of 216 and the cube root of 8. I know that the cube root of 8 can also be written as the cube root of 2 times 2 times 2. Since I see 3 copies of 2, because it's a cube root, I know that the cube root of 8 is 2. I can do the same thing with 216. I can rewrite it as the cube root of 6 times 6 times 6. And because I see 3 copies of 6, I know the cube root of 216 is 6. Rational exponents. An exponent which can be written as a radical, they're often fractions. So the fraction is going to be the power over the root. So whatever number is on top of the fraction stays with the x, and the denominator becomes the root of the exponent. Of the radical. So for example, 27 over 1/3 and x to the 6th half. So this is going to be the square root of x to the 6th. 6 stayed as the power and the square root went to the front. So I could write this as simply the square root of x to the 6th. When there's not a power written in the front, we understand that it is a power of 2. The same thing with the 3. For the 27 to the 1/3, the 3 is going to go with the radical. So cube root of 27 to the first power. But we know we don't have to write that power, so we have the cube root of 27. So anytime I have a power that is a fraction, I can rewrite it as a radical. So let's practice. We're going to rewrite each radical as an exponent. This is going to go in the opposite direction. So this time I have the 5th root of 3 squared. So we know that 3 is our base. And then remember that it's the power over the root. Our power is 2 and our root is 5. So this is 3 to the 2/5. Our other example is 6th root of x to the 4th. Remember, it's power, which is 4, over the root, which is 6. In this example, we're going to rewrite each rational exponent as a radical. So we have x to the 8/3. Remember, once again, that it's power over root. So the root of our radical is going to be 3. And then so we have x, and then the power of our x is 8. Now, over here on the second part, let's rewrite this. This is x times y to the 2/3, because y is only with 2/3. Now, if it was written like this, where xy was raised to the 2/3, then that would be different. But because 2/3 is only touching y, our radical is only going to go around y. So we have x times, and the root of our radical is 3 because that was our denominator of our fraction, and then y squared. If we were written how I wrote it to the right hand side, then we would be the cube root of x xy squared, or you could write it as the cube root of x squared y squared. All of those would be correct. Okay, in this example, we're going to simplify the expression. We have x times y squared to the 1/2. Now, this is what I was just talking about in the previous slide. Our 1/2 goes to everything. So that's going to be the square root of xy squared. But we need to finish simplifying this. Can we take the square root of x? No. Can we take the square root of y squared? Yes, that's going to be y square root of x.